Welcome to Survey Matters with Duncan-Parnell. My name is Mark White, and I'm the Training and Support Manager for DP. Today I want to talk to you guys about doing a field calibration on your S Series instrument. But first, please like and subscribe. All right, so I am out in the field today at our office, and we are near the airport, so if you hear jet noise or some delivery trucks coming by, maybe a few disturbances here. But today I want to talk to you guys about doing a field calibration on your S Series instrument. Now, I'm out here with a Trimble S5 robotic total station, but this will work with S5, S7, S9. Won't work with the SX12 because of the cameras. You have to do your calibration a little bit differently there, okay? In the description, I'm going to put a link to this PDF that we have that kind of walks you through this whole process, all right? And I've got it out here with me just to make sure I don't miss any steps. I actually want to kind of read through some of the things that Trimble says to do, but this is straight out of the S5, S7 user manual. And again, I will put a link in the description where you can download this, okay? So, why should I do a field calibration? Well, one of the support questions we get on a regular basis from guys running robots, especially running traverses, they have some trouble with their traverses closing. So we'll get a phone call like, man, I've been running traverse with my S Series instrument and I can't get my traverse to close. 99.9% of the time when I talk to those guys, they're not doing field calibrations. And doing a field calibration before you do any kind of highly accurate measurement is recommended, and we'll go through that here in just a second. But that's kind of why I want to cover this, okay? Mainly for people that are having trouble closing traverses, but it's gonna just make your instrument more accurate. You should bring your instrument into the office at least once a year and have it calibrated at a Trimble authorized service center. But then from time to time, you're still gonna need to run a field calibration. And just out of the manual, let me read a few of the times that you should do that. Flip through the pages here. So for the compensator calibration, which I'm going to show you how to do, Trimble recommends that you regularly carry out a compensator calibration, particularly when measuring during high temperature variations where the highest measurement accuracy is required, okay? So temperature affects that compensator, so you'll want to do that. Then there's also the horizontal and vertical collimation that we're going to do. Let me flip over to that page real quick. So collimation errors will change over time according to the manual due to wear tear with use, bumps and knocks during transit, and then large changes in operating temperature like we just talked about. So Trimble recommends that a collimation check and tilt axis check be carried out routinely after long uncontrolled transport of the instrument, like let's say you have to ship it somewhere, after any kind of accidental knocks or drops, hopefully you're not dropping your instrument, at any time when the operating temperature changes by more than 10 degrees Celsius or 18 degrees Fahrenheit, at any time the instrument changes its height above sea level by more than 500 meters, that's 1,640 feet, at any time when the highest accuracy positions are required. Again, if you're doing a traverse, run a field calibration before you do that traverse, okay? And then routinely on a periodic basis. They use monthly as an example, okay? So those are some of the times when you might want to do a field calibration on your instrument and reasons why you would want to do it. All right, so let's get down to how to do that now. Now, I've got a prism set up about 500 feet away down the way here, and you want to kind of set your prism up in at a distance that you're normally going to traverse at, right? So if you're traversing 500-600 feet, it's a good idea to set your prism up at about the same distance. The other thing you want to do is make sure you do this early in the morning or late in the afternoon. You don't want heat waves. Now, today it's 60 degrees and cloudy here in Raleigh, North Carolina, so I've got ideal conditions for doing this, all right? But if it's a sunny day out, you know, whether it's hot or cold, if it's a sunny day out and you're having heat wave problems, make sure you do this in the shade. Do it early in the morning, late in the evening, okay? So, first thing, I'm gonna turn my instrument on. And when the instrument pops on, we're gonna do the collimation or the calibration through phase 2. You can also do it on the data collector. I prefer to do it on the robot. So it says it's booting now, then it's got an option for setup level. So I'll tap the enter button and it's gonna open up the level screen. And you wanna make sure that the instrument is as level as you can get it. It's gonna pop up at 1 and 250 first. And I'm just gonna use 2 screws to level it this way and 1 screw to level it this way. So I'm gonna get it as level as I can at 1 and 250. Then I'll hit the down arrow and go to 1 and 100. And I'll level it up in 1 and 100. Now, 1 and 250, you'll have to turn the screws a little bit. As you go to 1 and 100, you'll turn them a little bit less. And then we'll go down to 1 and 10, and you'll see that you don't have to turn the screws very much at all at 1 and 10. All right, so I've got it dialed in pretty good at 1 and 100. I'll go down to 1 and 10. And like I said, now that we're zoomed into 1 and 10, you barely have to touch the knobs to get it to move. So we'll move it in very small increments. And we'll get this thing dead level at 1 and 10. There is also an option for 1 and 1. What I find is if you even breathe on the instrument at 1 and 1, it's gonna knock it out of level. So 1 and 10 really gets you down within a few seconds of level, so that's gonna be fine. So I'm dead level at 1 and 10. I'm gonna tap the enter button to choose setup, and that's gonna take me to my setup menu. Now I'll use the down arrow to scroll down to adjustments. There's a little arrow on the side of the screen. When that little arrow gets on adjustments here, I'll tap the enter button again to choose adjustments. The first adjustment in the list is the compensator calibration, okay? You really don't have to do anything for the compensator calibration. The instrument's gonna do everything on its own there. So I'll hit the enter button to choose, or I'll scroll down, excuse me, to the compensator calibration, hit the enter button to choose it. It's gonna come up with a message, excuse me, that says, ensure the instrument handle is intact, okay? Everything has to be perfectly balanced on the instrument for this, so we'll make sure the handle's on there. It is, I'll hit enter. It'll say, ensure a control unit is not attached. There is no control unit on here, so I'm good there. And then I'll hit enter again. And now it's gonna go ahead and balance the instrument. You do wanna make sure a battery is in it as well, an internal battery, that you're not running it off of external power. So now the instrument's it says balancing, now it's gonna say it's doing the compensator calibration. So it's just gonna slowly turn around. Again, you don't have to do anything with this, except make sure it's level before you start and make sure everything's on there. So we'll just let it spin around and do its thing now. And once it comes back around here on the screen, the scope will flip back over. It says compensation complete, and then it goes right back to the adjustment menu, okay? If there's something wrong with your compensator, it may fail and come up with an error message. In that case, just make sure that the instrument was level and try again. If it does fail again, then you can take it into your local service center to have that compensator checked there. But that's all there is to it. Okay, the next thing we want to do is the HAVA collimation. So I'll scroll down and hit the enter button again to choose HAVA, and it's going to pop up and tell me what my current values are. In this case, it says negative 0.0004 and then zeros all the way across for the VA. All right, and then there's an option for continue and cancel. Now what I need to do for this is have a target that's at least 100 meters away, preferably again about the length that you're normally going to traverse. So if your traverse leg's around 400 or 500 feet, pick something that's about 400 or 500 feet. It could be a prism, but it doesn't have to be. You could use the T on the stop sign, you know, a corner of a building, just something that is easily identifiable, easy for you to see, so that you can turn to it repeatedly. All right, now I got a prism set up down there, and unfortunately it looks like a Duke Power guy is standing in front of my prism. Hopefully he'll move here in just a second. But once I'm ready, I'm just going to use the target around the prism to sight to, because it's something that's clear and easy for me to see. Okay, so I will choose continue, Now it's gonna say new observation or change face. I wanna start in face 2. So I'm gonna scroll down to change face and hit the enter button. That's gonna change the instrument over to face 2. I know it's in face 2 because Trimble's upside down here. All right, my prism's this way, so I'm gonna use the knobs to, again, sight on something that I can see clearly, and then I will hit the enter button for new observation. All right, and I'm gonna do that 5 times in the second face. Then I'm gonna use the arrow to choose change face again and do that 5 times in the first face, sighting the same object every time. You're basically telling the instrument horizontally and vertically where 0 is at that same point every time to collimate the instrument there. So I will focus on my prism down here. Again, I want to be gentle with the instrument. I want to use the knobs as much as possible so that I'm not disturbing the level on the instrument. And I'm just going to use, like I said, the target on there. You could use the prism, you could use something else. I'm going to actually use the target to line up with. All right. So I'll hit the enter button for new observation. Now it says face 2, 1 observation. I'm gonna turn slightly off horizontally and vertically and then sight it again. And once I've sighted it again, I'll hit enter for observation, new observation. Now it says face 2. So I'm gonna do that 3 more times and I'll bring you guys back when I'm ready to change face. Okay, so I've done 5 observations, sighting the same point horizontally and vertically, turning off just a little bit each time and re-sighting it in face 2. I'll use the down arrow to go to change face and go ahead and go to face 1. Now I'm gonna sight the same point in face 1, turn off, sight it, turn off, sight it, hitting new measurement or new observation each time till I get 5 in face 1 as well. Then I'll bring you guys back for the end. Okay, so I just finished up in face 1. I've got 5 on each, and it tells me now that my new values are 0008 on the horizontal and 0004 on the vertical. If it's too far out, it will give you a message that you need to take it in for service, okay? That it's out of range, and at that point you should take it in for service. But now I've got a good HA and VA collimation done. The next option I have is either to do a trunnion collimation or to store the correction. I'm gonna use the down button and choose store correction and skip the trunnion collimation. If you do a lot of straight up and down vertical work, like running control up and down a building, do the trunnion collimation. If you do normal survey work, just regular traverses, topos and things, the horizontal and vertical will suffice, and get the trunnion done once a year at the office. Now, one thing I forgot to say about the HAVA, you do have to be on a fairly flat surface. Make sure that what you're sighting is no more than 4.5 degrees above or below the horizon there, okay? So you've got a pretty flat surface that we're actually measuring on. Once we're done with the horizontal and vertical collimation, we'll scroll down to the tracker collimation. So I went down arrow, tracker collimation, tap enter. It's gonna tell me what my current values are, and I'm gonna go ahead and choose continue. Now, all I have to do for this is have a prism set up at least 100 meters, preferably about the distance you're normally gonna traverse. I've got mine out there again, 400 to 500 feet. So I'll hit continue. It's gonna tell me to aim at target. So I will make sure that we are aimed at the target, and we are, and then it's gonna auto lock on the target. And again, I don't have to do anything but go ahead and hit the enter button for new observation. Now the instrument is gonna start measuring on the prism, and it's gonna collimate that tracker or calibrate that tracker. Now what this does, if you ever looked through the scope and you've seen maybe when it's in track mode, the crosshairs are not perfectly on the center of the prism. By measuring it in the first face, measuring it, flipping over and measuring it in the second face, the instrument can figure out where the center of that prism is. If it's tracking high and left in one face, it'll be low and right in the other. Then it knows the values where the center of the prism is, and it can apply those values when the instrument is in track mode, so you're actually measuring to the center of the prism all the time. Okay, so once that's finished, it's going to pop up and it's going to tell me what my values are. I'm getting 0.0015 in the horizontal, negative 0.0016 in the vertical. Again, if it's out of range, it's going to pop up with a message to tell you it's out of range and you should take it into your local service center. At this point, I have the option to store the correction, so I will hit the enter button to store correction. It says storing, and then it's going to take me back. It says it's stored successfully there. It's going to take me back to the adjustment menu, and at this point, that's all I'm going to do. I did a compensator calibration, I did a horizontal and vertical angle collimation, and I did a tracker collimation, okay? So I'm going to scroll down till my little arrows come back to the back button, hit enter there, and I'm going to scroll down again until I get exit to the level bubble, and hit exit there, and the instrument will go on to its setup mode where it's looking to connect to a data collector. So that's all there is to doing a field calibration. Again, anytime the instrument's been shipped, anytime the temperature's changing more than, say, 18 degrees average highs, and I know in the Southeast that could be quite often, anytime you're getting ready to run a traverse, do a field collimation, and do it to the prisms you're gonna use. You know, you use your traverse kit prisms there that you do your collimation to, your tracker calibration. Make sure you do your horizontal and vertical collimation on fairly flat ground. Make sure you don't have a lot of heat waves, and you guys will be able to close traverses a lot better and just keep the accuracy of that instrument at peak condition. Well, hey, thanks for stopping by today, and we'll see you on the next one.